Right, area under the curve. First thing before we start with area under the curve, the following are important. So take down the two in the top right corner of your copy just so we have it. So we're finishing up integration today. Anyone who missed last week, the video is up online anyway, so you can have a quick look back through it. Right, so just to explain these two, very important when we're integrating. This here is a cubic curve, i.e. it would be, for example, that would be something like x cubed plus 2x squared plus 3x plus 4. Cubic curve. How do I know it's cubic? Two terms. 1, 2. Alright? Also puts the x-axis in 1, 2. 3 x's. That's how I know it's cubic. In a cubic, if it goes above the line and below the line, you must integrate both areas separately. And this area down here is going to be negative, so you must get the absolute value. You must get the absolute value when we're dealing with area anyway, but you be careful of that. That's going to be negative down here, so you must get the absolute value. Over here, you have the integration of a quadratic and a line. So very, very, very important when we're doing this is you must integrate from the line down and then integrate from the curve down. Alright, so these are two different separate situations that come up. It's either generally going to be one or two of these. We're going to start off with some easier ones, but generally on the exam papers it's either going to be one of this or this. Alright, it's not going to be a nice and handy one. It's going to make you do a bit of work. It's not going to be a straightforward integration. So for this one over here, it's right. First things first, then we have to make sure we're okay to this. So we know we're integrating this. What is integration? Very, very important. You know what integration is. Take it out of your copy. Calculating. Here. Integration is calculating area. Differentiation, anyone remember what it is? Calculating slope, good stuff. There's no such thing as straightforward questions in 7, 8, and 9. 7, 8, and 9 is all practical application. If you don't know what you're doing, you're all shit screwed. 1 to 6, you're grand, it's just basics. 7, 8, and 9, if you don't know what you're doing, if you don't physically know what you're actually doing, you're in serious, serious bother. So we must actually know what we're doing. Integration is calculating area, differentiation is calculating slope or change. Slope is change, but just so you know that's an important word for differentiation, change. Right, integration of a line. Integration of a line or a curve is calculating the area between said line / curve and the x-axis. Now, it's not always the x-axis, but I'll explain the situation and then when it's not the x-axis. These are all important little notes. Calculate the area between said line / curve and x-axis. Right. Here's an example. It's on picture 1. equal to x squared minus 4. So, say curve here goes between, in the difference say that it's going to go between, or factorize it's going to go between 2 and minus 2. Here's your curve. If you integrate that, what you're actually doing is calculating the area taken up in there between your curve and the x-axis. That's what you're actually doing. Very important for me to read these questions. So calculating that. So, start with the basic. We're going to integrate the following function to the x-axis. So integrate the following function to the x-axis. So anyone know how we're going to set this up from the start? Integration of x plus 1 so that's to finish it off. The integration of x plus 1 between 4 and 1. If you don't say between 4 and 1, all you're actually doing is you're getting the area from all the way up here and continuously all the way down here. 4 and 1 means you only want it in that section. You're doing the integration of x plus 1 between 4 and 1. Don't forget your rules of integration are on page 26. So integrate that and you get x to the power 2 over 2 plus x between 4 and 1. That is 4 to be squared over 2 plus 4 minus 1 to be squared over 2 plus 1. 4 to be squared over 2 plus 4 is 16 over 2 is 8 plus 4 is 12, is it? Minus 1 to be squared is 1 1/2 plus 1 is minus 3 over 2. And we get 10.5. units squared. That means the area inside here is 10.5 units squared. And that's what you have to calculate. Is that right? What that means is the run from this line all the way to this, where this hits over here, that's 12 units. The whole way from here down to here, that's what you have to calculate there, it's 12 units. The 3/2 units is that this is from here down to here. So that's why you're taking it away. You don't want the whole way from here all the way over to where this line runs on and connects here. You only want it from here over to here. From here to here is 12 units. From here over here is 3/2 units. That means literally taking away 3/2 units from your full 12 units and you're left with 10.5 units. That's what you're after. Very important that you have to understand this, because in a minute we're going to be doing underneath the curve and above the curve and above the line and underneath the line all in one question, and you have to actually be able to visualize what you're actually doing at the time. Because if you don't, you're going to get very, very confused. Right. Let's have a go at this one. Off you go. Integrate the following, calculate the following area for me. We can have that one again. I seem fairly happy with 120. So that is the integration of 2x cubed between 4 and 2, which is, integrate 2x cubed, we get 2x to the power of 4 over 4 in between 4 and 2, which is x to the power of 4 over 2 in between 4 and 2. That is 4 to the power of 4 over 2 minus 2 to the power of 4 over 2. 4 to the power of 4 over 2 is 128 minus 2 to the power of 4 is 16, is it? 16 over 2, which is 8, is equal to 120 units squared. And that's it, 120 units squared. That's what you calculate. Right. To make things a small bit more difficult. Let's have a go at number 4. So, here's our first one where we're above and below the line. Right, so do here. We have 4 minus x squared is our curve, and it goes up, goes back down, and they want us to calculate the curve. Anyone, any idea what I'm going to do? Sorry? We'll take them away from each other now. So, for example, am I going to do it all together? No, I'm going to worry about A1 and A2. That's the first thing you do anyway, is label A1 and A2. The reason you label A1 and A2 is you have to let the person know who's correcting it, what you're doing. It's all about letting the person who's correcting it make the job as easy as possible for them. Don't forget they have 100 and something, they could have up to 200 and something scripts in front of them. Make their job as easy as possible and they'll like you and you get extra marks. Simple as that. So, we're splitting it into two, A1 and A2. Adam, how am I going to integrate A1? I'm going to integrate. Curve doesn't change. It's 4 minus x squared. The curve does not change. It's the same curve. 15? Minus 2 and minus 3. Minus 2 and minus 3. That's going to give me that area inside there, A1. Ellen, I need to get A2. What am I going to do? I need 2 and minus 2. You always start with a higher number and work about that. Is that alright? Very, very important. What's the problem with this one going to be more than likely? It's going to be? Because it's down here? Negative. So make sure you get the absolute value. Alright, make sure you get the absolute value. Off you go. So just even if you want to remind yourself, put your little red lines or something outside them so you know you've got to get the absolute value of that. Make sure your answer is positive. Give me a shout, guys.
What are we going to have? What do we have? 13 units. We'll look in a minute. Right, let's have a little go at it then. So, integrate 4 minus x squared and we get the integration of 4x minus x cubed over 3 between minus 2 and minus 3, yeah? And that's going to be plus the integration of same curve, so it's 4x minus x cubed over 3 between 2 and minus 2. 4 times minus 2 minus times minus 2 to be cubed over 3 minus 4 times minus 3 minus times minus 3 to be cubed over 3. And don't forget absolute value of this. So straight into the calculator, probably the easy way, you won't make a mistake there. 4 times minus 2 minus bracket minus 2 to be cubed over 3 minus 16 over 3 minus, back and change your numbers to minus 3 and minus 3, and we get minus 3. So minus 16 over 3 over 3 minus minus 3 is plus 3 is minus 7 over 3. We want the absolute value, so that becomes 7 over 3. We happy with that? Good stuff. Right. Plus, we're going to add in what we do over here. It's 4 times 4 times 2 minus times 2 to be cubed over 3 minus 4 times minus 2 minus times minus 2 to be cubed over 3, and that is 4 bracket 2 minus bracket 2 to be cubed over 3, which is 16 over 3, minus, we did 4 minus 2 over here, which is minus 16 over 3. So that's 16 over 3 plus 16 over 3, which is 32 over 3. 32 over 3 plus 7 over 3 is 13 units. Are you happy with that? And I won't lie, generally when you get an answer like that, you're fairly right. If you get it, if you give a bang on answer like that, you know you're going to be fairly right, generally. So that means that entire area, that was, this one over here is 32 over 3, this one over here is 7 over 3, add the two of them together and you get 13 units. Right. Let's do another slightly harder one. Above and below, no, I don't want. Yeah, here we go. One of these. Right. Was that example 4? 3. Right. So, first thing we got to logically figure out what we're doing here. Element. If you integrate 4 minus x squared here between 2 and minus 2, what are you actually getting? Sorry? Not the area under the paradox or above this line, so if you integrate 4 minus x squared between 2 and minus 2, what you're actually getting is, what the easiest thing to do is do it on the actual screen itself, is you're going to go and get all of this. That's what you're getting. If you integrate 4 minus x squared between 2 and minus 2, that is what you're after figuring out. Gavin, that's not what we want. We only want what's important, don't we? So if I asked you to integrate x plus 2 between minus 2 and 2, the problem is it's going to run up there, so we're going to go between minus 2 and 1. What do you do if you integrate x plus 2 between minus 2 and 1? I'm going to draw, for all the world, I'm going to draw a line here. Jeez, that's a terrible line. Right. What do you have to do if you integrate between x plus 2? If you integrate x plus 2 between 1 and minus 2, any idea what you're after doing? If you integrate x plus 2 between 1 and minus 2, you're after getting that. That's what you're after getting. You're after integrating what's below the line between 1 and minus 2. Now, so Adam, you have a problem. Our problem is when we integrate 4 minus x squared, we're getting all of this. And when we integrate x plus 2 between 1 and minus 2, we're going to get all of this. So what are we going to do? That's the problem. We still have this over here, don't we? How are we going to solve the problem? Find it. Yeah. So Adam's right. You're going to do an equation and figure out the points of, which is going to give us 1 and 2. Yeah, so that's just going to prove our point. They intersect at 1 and minus 2. How is that going to happen? No need. This is what I'm on about. You have to logically be able to see what you're integrating, figure out, because this is the way they're going to pop it up during the exam. We're going to integrate 4 minus x squared between 1 and minus 2. If I integrate 4 minus x squared between 1 and minus 2, what's that going to give me? It's going to give me it's going to give me this. Isn't it? It's going to give me all that area there. But I don't want all that area there. I want only what's in purple. So how am I going to get rid of what I don't want? I'm going to integrate my line. minus, I'm going to integrate my line, which is x plus 2 between what? 1 and minus 2. Integrate my line between 1 and minus 2, what's that going to give me? This inside here, isn't it? So if I have the whole thing and take away what's in green, what's it going to leave me with? What's in purple. Alright, so very, very important to see what you're going to do. So it's grand and handy here that we can graphically see that it's 1 and minus 2 is the point of intersection, isn't it? It isn't always going to be that easy. What Adam says is more likely what's going to happen in the exam is you're going to have to do a simultaneous equation between x plus 2 and 4 minus x squared to see where they intersect first. Is that alright? This one is grand and handy. We can see it on the graph. But normally you have to do a simultaneous equation between x plus 2 and 4 minus x squared to get your 2 points of intersection. Then integrate your curve. Then integrate your line and take your line away from your curve. It's a pretty long question that comes up on question 7 there. So off you go. See if you can get me an answer out of that. right there, so that finish off. You got it out? Okay, good. 4.5 seems to be the running number. Right, so, as I said, even if you want to write over it sometimes what you're actually doing. This is my curve, this is my line. It's always handy just making little notes, especially when you're looking back. You can be looking back at this in a month's time, well, 2 weeks' time before your mocks. Some of you are doing it before midterms, some of you are doing it after, so something like this could be coming up. It's always handy to make little notes when you're looking back. So, let's integrate 4 minus x squared first of all. That is 4x minus x cubed over 3 between 1 and minus 2 minus x squared over 2 plus 2x between 1 and minus 2. Right, so that is 4 times 1 minus 1 to be cubed over 3 minus 4 times minus 2 minus minus 2 to be cubed over 3, which is 4 times 1 minus fraction 1 to be cubed over 3, which is 11 over 3, minus 4 minus 2 times minus 2 to be cubed over 3 is minus 16 over 3. And over here then, this is once again, this is your curve. This is my line. That is 1 to be squared over 2 plus 2 times 1 minus 2 to be squared over 2 plus 2 times minus 2, which is 1 to be squared over 2 plus 2 times 1, 5 over 2. If you're getting different answers here, lads, give me a shout just in case I made a calculation mistake. Minus minus 2 to be squared over 2 plus 2 times minus 2, which is minus minus 2. Right, that is 11 over 3 plus 16 over 3 is 9 minus 5 over 2 plus 2 is 4.5. Happens again. And then 9 minus 4.5 is equal to 4.5 units. Just calculator mistake, was it? Alright, simple mistake to make. We're going to do one more of those and then we're going to jump into the exam paper questions, alright? So I'm going to let you try to figure out this one on your own without a bit of help. See if you can work it out. Yeah, this is literally something you're going to be getting. So like Adam said, they don't always give you the sketch. Sometimes, Jesus Christ, sometimes you have to work it out yourself. Have a go at this. This is example 6. 4. So your function of x is x squared plus 3,
and g of x is 3x plus 1. Fx and gx meet at the points A and B. Find the coordinates of A and B. I'm going to go find the coordinates of A and B. Good man. So the basic equation. So the basic equation. Sketch it. Then find your area. Off you go. It's going to take about 10 minutes. Could take you 15. Jackson, 2 seconds. Did you start working here? Just make sure you know what to do. You all know how to sketch a line and sketch a curve? Do it right. You know, we sketch a line and sketch a curve, which we do right. You sketch a point of intersection, right? You can sketch two. Oh, one sketch this and this. Factorize and find where it cuts the x-axis. 3 tells us where it cuts the y. Same with this one. Last number tells us where it cuts the y-axis. And get our slope then on it, so we know 2 points. Make sure you sketch the 2 of these right. If you sketch the 2 of these, you get marks. You get generally marks for this. So if this is generally probably an A, a B, and a C. A will probably only be about 5 marks, is only a simultaneous equation. B will get 10, and this will be another 10. With 25 marks. So you have to make sure you sketch your graphs correctly as well. Very, very important. So the units are worked there. I.e. x squared plus 3. Factorize that to figure out where it cuts your x-axis. It has to be done as a rough sketch. So we can't factorize it, just minus d it to tell you where it cuts your x-axis. So for example, x squared minus 3. So whatever square root plus or minus the square root of 3 is. So we have 1.7 and negative 1.7. And that I got there is 3. Where it cuts the y-axis. And you do the same here. 9.
Oh, it's positive anyway, so it's the other way, sorry. It's U, not in. Positive curve. So it should be the other way around. Oh. I don't know why you did it. I took it straight out of the book. I never done it before now. It's a horrific graph to draw. That is, yeah, it's not sure that is. It's the square root of minus 3, and this is the square root of 3. And minus square root of minus 1. And x equals 3. That's a complex number graph, it's an imaginary graph. Yeah, just so you know what it looks like. Yeah, it's U-shaped, but like it looks like this, because I was looking at it there, it didn't make sense. It literally looks like this. It's a horrible graph to draw. I don't know how they, probably why it's in the textbook and not in the exam papers. It wouldn't be this hard. Okay, don't scroll in for me. You don't want to scroll in? So there's the problem. Because it's an imaginary graph, i.e. it's all the way up here, and your points of intersection are 4 and 7, are they? Did you get it? 2 and 1? No, that's it. They wouldn't give you one like that anyway. Like they'd make sure plus the x-axis. That's an unfair one, right? Must be a problem with the question, because that's what it looks like. Sorry, 2 secs, I'll pick a nice one. 2 minutes. Apologies about that. As I said, I'd never done it before, so I was kind of wondering what was going on there. Right, this one's much nicer. Find the points of intersection of y is equal to 5x minus x squared, graph the two, and calculate the area bounded between the curve and the line. So find the points of intersection of y is equal to 5x minus x squared and y is equal to 4. Yeah, that's a much nicer question. Sorry about the last one. I didn't realize it came straight out of the book. Find the points of intersection of y is equal to 5x minus x squared. Y is equal to 4. Graph the two and calculate the area bounded between the curve and the line. There are 3 steps for that question as well. Find the intersection, simultaneous equation, draw the quadratic, you factorize for x and get your 2 values for x, draw the line, use y equals mx plus c. Step 3, get the area between the two, and integrate. That's how you go about that question. Step 1, 2, 3.
for your point of intersection or your curve. So you know that it's going to go 1 is going to go through 4, right? As you factorize this, solve it from 0, see where you're, see where that goes through your graph then as well. Alright? I think the first bit is catching slightly, catching is awesome, right? And let's explain what I mean. It is important we get our head around this because this is a question that comes up. So, step 1 is we get the point of intersection. And every time we get something, it's all about visualizing it. So we draw a rough little sketch every time we do something, right? So, point of intersection, y is equal to 5x minus x squared, and y is equal to 4. To get the point of intersection, we need the two be equal to each other. So y is equal to 4, that 4 is equal to 5x minus x squared. Therefore, x squared minus 5x plus 4 is equal to 0. Bracket, bracket, guide number minus b. X and x, minus 4 minus 1. X equal to 1 and x equal to 4. Right. What that means is this a positive or negative curve? Negative, isn't it? And this is a straight line, isn't it? So it's going to be an N-shaped curve. And on our N-shaped curve, there's our line running across it, positive line. It's going to intersect here at the point 1, and it's going to intersect there at the point 4. Is that alright? There's where it's going to intersect. That's only the first bit. Now we have to sketch them. To sketch them, step 2 is we have to factorize our quadratic and solve. So factorizing and solve our quadratic is we leave it equal to 0. So that's 0 is equal to 5x minus x squared. Take out a common. I'm going to move everything to right actually, make things a bit easier. X squared plus 5x is equal to 0. Is that alright? Take out a common x. You're left at x plus 5 is equal to 0. Line down the middle. X equals 0. X equals minus 5. I brought, oh, that should be minus 5 actually, yeah. And go at it, x minus 5, and that should be x plus 5 then. That means, boom, boom, there's your curve, and it goes through 5 and 0. Is that alright? Next one. These are all just rough little sketches first of all. We gotta draw our line. Our line is equal to y is equal to mx plus c is our formula, and y is equal to 4. Anyone able to tell me anything about y is equal to 4? Sorry? It's a horizontal line exactly across the y-axis at 4. And there's your horizontal line. Is that okay? Now, you'll be given, if they're asking you, they won't ask you to graph out the x's, x and y. You'll be given the axes, x, you'll be given the x and y axis, so it's exactly right. You won't have to spend 5 minutes with a ruler doing it. So, just to make life a bit easier, I'll do it on this. Oh, it's being fairly awkward today. Now, there's two or three of these in the homework tonight. I recommend that you practice them because they do come up. Is that alright? So, first things first is we're going to sketch our quadratic. So our quadratic goes through 0 and 5.
and we'll go to that point, right? And our line goes through y equals mx plus c, so it's a horizontal line across 4. There's your horizontal line across 4. They intersect at the points, where do they intersect? 1 and 4. So we're going to have a point of intersection here at 1, and we're going to have a point of intersection here at 4. Is that alright? There's your point of intersection. Let's draw our curve. So we know it goes up through this. It comes back down through that. And there's your sketch. Is that alright? So, back to our question then. The last bit of our question, it asks us, graph 2 and calculate the area bounded between the curve and the line. Right, how are we going to get the area between the curve and the line? Do you need to take it down any more of that? Or you all let down? You all okay? Good stuff. Right, how are we going to get the area between the curve and the line? So just so we know what we're talking about, my curve is y is equal to 5x minus x squared, and my line is y is equal to 4. Integrate. Exactly. We are going to integrate our curve between 4 and 1. So we're going to integrate 5x minus x squared between 4 and 1. Once again, all about visualizing what you're actually doing. What that does is it gives you all of this. That's what between 4 and 1 gives me. Right. Ellen, I don't want all that. What am I going to do? Going to integrate your line. So this is my curve. And this is my line. Going to integrate my line between what? Between 4 and 1. And my line is 4. Right. When I do that, I'm after getting all of this down here, am I? Very important that we know what we're actually doing. There's my line there now, all in pink. So am I going to add them or take them away? Take them away, exactly. Boom. And there's your answer. Is that alright? There is your exam paper leaving cert question. Off you go. We're going to finish that.
Right, and I'm a little look at it. So,
integrating my curve then, I get the integration of 5x squared over 2 minus x cubed over 3 between 4 and 1. That is 5 times 4 to be squared over 2 minus 4 to be cubed over 3 minus 5 times 1 to be squared over 2 minus 4 times 1 to be cubed over 3. Gav, did you get an answer here? You put it all into the calculator and we get an answer for that one there, no? 5 times 4 to be squared over 2 minus 4 times 4 to be cubed over 3. No, that should be a regular one. Very good. 56 over 3. We happy with that, guys? And then 1 and 1. 13 over 6. And then your second one minus your line, which is 4x between 4 and 1, which is minus 4 times 4 minus 4 times 1, which is minus 4 times 4 is 16, minus 4 times 1, which is minus 4, which is minus 12. 56 over 3 minus 13 over 6 is? $33 over 2. Final answer of 4.5, 9 over 2. Did I make a mistake? Double check it. 4 times 4 is 16, 4 times 1 is 4, 16 minus 4 is 12, 33 over 2. Say I'm fairly right there. Yeah, 16 minus 5. Right, exam paper question. Let's jump into it for the last 15 minutes. So, paper 1, question 6. Parts of the graph of the function, the h of x is equal to x, and the k of x is equal to x cubed, are shown in the diagram below. Part A is find the coordinates and point intersection graphs of the two functions. Right, so it made it a lot easier for us in this one, thank God we don't have to draw it. We'll still have to do step 1 and step 3. Yeah, step 1. I'm going to figure out length intersection. Simultaneous equation, math. Right, I'm going to do a simultaneous equation of these two. X equals x cubed, and exactly off you go and get your. How many points of intersection am I going to have? 3. I have 1 down here, and 1 here, and 1 there. 3 points of intersection. Off you go and get my 3 points of intersection. Get a value for 1. If you're ahead of me, the second part of that question is find the total area enclosed between the two graphs of the function. So in here. Right, so just make sure we're all on the right point anyway, lads. We want to find the points of intersection, which is 1, 2, and 3. So we leave x x cubed equal to x, so that's x cubed minus x is equal to 0, isn't it? Take out a common x, you're left with xb squared minus 1 is equal to 0. How are we going to finish it off from here? X is equal to 0, exactly. What's this difference of? That's x minus 1 by x plus 1 is equal to 0. X is equal to 1, x is equal to minus 1. There are your three answers for x. How am I going to get my y's? Sub it back into the equation. So, I know that when x cubed minus x is equal to 0, when x is 0, that's 0 to be cubed minus 0 is equal to 0, that's 0, 0, isn't it? When it's 1, one to be cubed minus 1 is 1, 0, because that's going to leave you off at 0. And when it's minus 1, minus 1 to be cubed, minus times minus 1. Minus 1 to be cubed is minus 1, plus 1, it's minus 1, 0. Or 1 second. No, you just sub them back into x cubed, sorry. Yeah. Yeah, you just sub them back into one of them. Yeah, you say h of x is equal, sorry, the k of x is equal to x cubed. Apologies. The k of x is equal to x cubed. When x is equal to 0, it's 0 to be cubed is equal to 0, so it's 0, 0. The k of x is equal to x cubed when x is equal to 1. K of 1 is equal to 1 to be cubed, which is 1, so that's the point 1, 1. And when k is equal to minus 1, it's minus 1 to be cubed, which is minus 1. That's the point minus 1, minus 1. Apologies. So there we know is 1, 1. There is our point 0, 0. And here is our point minus 1, minus 1. Right. Someone talk to me. What are we going to do? We're trying to get the area in between, bounded in between them. We're doing this bit down here. We're getting the area enclosed between the graph of the two functions. What do we know first of all anyway? Brilliant. Very, very important. They're symmetrical. Because by spotting that, you've saved yourself probably about 5 to 10 minutes work, which is important. Because you're going to be under pressure when you're doing your mock, especially your mocks. You're not going to finish your mocks, so don't be too worried about that. You're going to run out of time. especially because you're going to be doing the DEBs and you're just going to run out of time. So don't be overly worried about your mock results. You're going to run out of time. Questions are going to be horrifically hard, but do as much and get on as well as you can. So, by them being symmetrical, what does it tell me? Brilliant. The area of the value at the bottom is the same as the area of the value on top. That means we only have to get one of them and double it. So, we'll worry about the one above the line because that's positive. How am I going to get the area of this atom? Integrate x cubed between 1 and 0. If you integrate that between 1 and 0, what do you get? Don't forget what I told you, that's very important to be visualize it. That's going to give you all of this. There's your curve. That's going to give you all of that. From 1 to 0. Now, are we taking the line away from the curve or the curve away from the line? We're taking the curve away from the line. Why are we this time taking the curve away from the line instead of the other way around, which we've always done? Because the line is all of this. That's your line. That's all that big triangle down there. From the line down to the x-axis. The area under the curve, we don't want the area from the curve down to the line, we want the area between the two. And the line is above the curve this time, isn't it, up here? So we're going to integrate our line down to our curve, and then we're going to take away the area from our line down to our x-axis, and then we're going to take away the area from our curve down to our x-axis. So this time it's going to be slightly different. It's going to be the integration of x, which is our line between 1 and 0, minus our curve, which is the integration of x cubed between 1 and 0. So for the first time ever, it's our line minus our curve. Do you now see why it's so important when we're doing these that you understand what you're doing? Alright, so off we go, have a whack off it. See if you can get me that. Yeah. One more minute to finish up, but we'll finish with this question. So I will be jumping back to integration, examining questions for the last section of 6 weeks. It'll definitely just be examining questions, it'll just be flowing. Spending 6 weeks going through paper 2s and paper 1s. So we will be getting back to these few moments. Right, let's have a little look at it. So then, that is the integration of x between 1 and 0 minus the integration of x to be cubed between 1 and 0. That is x to be squared over 2 between 1 and 0 minus x to the power of 4 over 4 between 1 and 0. That is a half minus, that's 1 to be squared, minus, that's 0 to be squared over 2, minus 1 to the power of 4 over 4, minus 0 to the power of 4 over 4, which is, that's a half, is it? Minus, that's a quarter, which equals a quarter units. Now, very important, what did I tell you earlier on? Quarter units is only this bit up here. What do we need? A1 and A2. So that's only A2. A1 plus A2 is a quarter plus a quarter, which is equal to a half. And just to finish off the question, on the diagram on the previous page, using symmetry or otherwise, draw the graph of k minus 1, the inverse function of k. Right, to do that now I'm going to rub out all this so we can get a good look at it. So, how are we going to get the inverse? Anyone know how to sketch the inverse of a function? Using symmetry. We literally use this line right here as our axis of symmetry. And it's like that. That's the inverse function. It's an axis of symmetry. It's literally like you're flipping it over the line. Is that right? It's an axis of symmetry. And that was 5 marks. Just drawing that. And these 5 marks will never come across, if you know what to do. Right, lads, I will see you next week, and we're jumping into complex numbers. No, we're not. We're jumping into sequence and series next week. Yeah, studies going on here, kid. Just take your 10-15 minute break.